All right, so check it out. Probability is the study of chance. And with probability, we first have to define what are called sample spaces and events before we can start working with the different types of probabilities. So sample space, if you're ever asked what's the sample space, it's just the set of all possible outcomes. So if you're asked to find the sample space of, let's say, rolling a six-sided dice, well, then the outcomes would be 1, 2, 3, 4, 5, and 6. That is your sample space. That's all your possible outcomes. Flipping a coin 2 times, what's your sample space? You could get heads, 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 tails, tails, heads, tails, tails. And that'd be all the possible outcomes there. But do be careful how they word this. Like this next example says flipping a coin 3 times and recording the number of heads. So the sample space here is how many times you get heads when you flip a coin 3 times. You can either get it 0, 1, 2, or 3 times. So you do have to be careful on how they present the question. And that's a really good difference between, part A, B versus part C. Now, an event is just the outcome. It's a subset of the sample space. It could be, flipping a coin 2 times, and what's the chance that you get heads twice? So heads twice would be one of the outcomes. Or heads 1 time would be 2 of the outcomes. Where it gets tricky is occasionally you get a question where they ask you for a lot. And the two that I've seen enough times are when you're asked to flip a coin 3 times or roll a dice 2 times. If this occurs, you just have to start by barreling through and getting all the possibilities, okay? So sample space for flipping a coin 3 times. To stay organized, you might want to consider 0, 1, 2, and 3 for either heads or tails. So you start off one end with tails, tails, tails. You start off the other end with heads, heads, heads. That's the ability of each end. Then let's say you get heads 1 time. It would be heads, tails, 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 heads, tails, and tails, tails, heads. Let's say you get heads 2 times. Then you could do tails, heads, 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 tails, heads, and heads, heads, tails, and kind of see the nice nature of working this all out. And this in total would be your sample space for flipping a coin 3 times. There's a total of 8 outcomes. So since there's a total of 8 outcomes, if you total those all up, then you can go ahead and start finding probabilities. For example, find the probability of getting 2 heads. Well, there's 3 out of 8 total. So the answer for part A here would be just 3 out of 8. No tails. Okay, no tails at all would be, in this case, let's see. Well, that's got tails, that's got tails, that's got tails, that's got no tails. So that'd just be 1 out of 8. There's only 1 out of 8 chance of getting no tails. At least 1. Okay, so for at least 1, well, that's a case where there's 1, there's more than 1, and it's all. So that's 7 out of 8. But I do want to give you a rule right now that at least 1 is also equivalent to saying 1 minus the none case. So if I have at least 1 tail, then 1 minus no tails, there'd be 1 out of 8, which would, of course, give you 7 out of 8. Definitely look over that again and consider that possibility for at least 1 is the 1 minus the none case. So that's a set of examples of flipping a coin 3 times. And then lastly, if you're ever asked to roll a dice 2 times, well then, if you think about the number of outcomes, that means there's 6 outcomes the first time you roll, times 6 outcomes the next time you roll. There's 36 outcomes total. Okay, so how do you organize that if you're asked for a probability question? This is what I want you to do. Ready? Start just writing through. It'd be a 1 and a 1, 1 and a 2, 1, 3, 1, 4, 1, 5, 1, 6. Like if you have to write this out, it would take you about 30 seconds to a minute. So I'm basically saying that you rolled a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Then repeat. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 3. Nope, see, got to be careful. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. Typing, you got to be careful. Writing, I think you'll get into the pattern. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Almost there. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. I feel like I'm practicing typing here. This is great. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And if you write this in such a way, it's actually really easy to spot numbers. Like, so for example, if they asked, find the probability of rolling, let's say, a 4. Well, then if you write this in this way, we can see that, or rolling not a 4, but where rather your sum is 4. Let's write that correctly, everybody. So find the probability that the sum of the 2 dice equals 4. Well, then written in such a way, what I was trying to get to is, check it out. It'd be, let's see. So 4 would be right here, these 3. A 3 and a 1, a 2 and a 2 and a 1 and a 3 would give you 3 out of 36, which you could reduce to 1 out of 12. But the whole point is, you'll see the diagonals will give you 1 and 1, which gives you 2, 3, 4, 5, 6. The main diagonal all adds to 7, all the way down to 12. So this is a little bit much, but again, these are the extreme cases if you ever get a challenging question dealing with the idea of sample spaces and then find the probability of those sample spaces.